Welcome. This video focuses on arrays and how they interact with functions. So we're going to start with a little quiz. In main, I declare an array with 5 elements, initialize it, pass it off to this function that takes in an array of integers that it'll call list. So I pass numbers into the function, and then I print out the list. What am I going to get? Well, we can go try this. So I've got that function here. Let's go ahead and run it. And I get 0x28FEAC. If you guessed that correctly, congratulations. So why did I get that? Well, remember that anytime we're dealing with an array, if we just say the name of the array, we're talking about that base address, right? The address where the array starts. When we call a function and give it an array, essentially we're going to just pass it this address. And that's what it uses inside the function. Because we're passing it the address of where our data is, arrays are effectively always passed by reference. They're not, technically that's not actually by reference, but it works the same way. When I call this bad print array function and give it numbers, the parameter called list ends up getting the memory address of numbers, and so list is essentially just a shortcut, a link back to that same chunk of memory, that same array. And anything that I do to list is actually going to happen to numbers. Right? So if I modify this array inside the function, I'm actually going to mess up the original list of stuff. And we can see this happen. So let's go ahead and, instead of printing out the list, let's change element 2 to be 100. And I'm going to put a breakpoint in right when we hit the function and start it up. So we're about to go into the function. I can see that numbers has this memory address. And there are the values. And now to go into the function, I need to press F11 or step into the function. And so now we're in the function and we're working with list, and list is showing me the wrong thing here. So one of the weird things about working with an array inside a function is we don't have a lot of context for the array. We don't know how big it is. There's a lot of information that C++ can keep track of for an array that's defined in the same scope that we're working, but once we pass it into a function, we kind of lose track of the fact that this is really an array. And so all we're seeing is the first element in it. To see what is really there, I have to do a special trick. So I know that list in this function is an array, so I have to right-click it and say change local display format and tell it, I want you to treat this as an array of 10 items. Or if it's more than 10, as a array of 1,000 items. All right, so I'm going to say treat it as an array of 10 items. And now what I get is 1, 4, 3, 6, 8, the actual values, followed by some random junk because there's only 5 valid elements. All right, we change list2 to be 100, so I'm going to hit F10 to step. All right, we've changed that. I'm going to hit F10 once more to come back from this function. And so now we're back in main, and I can see that numbers got changed. Numbers and list are really the same thing. We pass in numbers and we work with it up here. It's just called list. List is essentially a shortcut back to the same array. So if you want to pass an array into a function and you don't want to modify it, you have to declare it const. Const int list array says, hey, I'm passing in this array, but I never want to be able to change it. And so then if we try and do something like this to change the value of list, the compiler will catch that and tell us, no, you're not allowed to do that. Anytime you're passing an array into a function, stop and ask yourself, do I intend to change it? If not, it absolutely should be const. All right. Next big thing is dealing with the length. So we have no way of looking at an array and knowing how big it is. Right? That's kind of exactly what we saw here with when I'm up in this function, I've got to tell the debugger, hey, just show me this as an array, and there's no real way to tell exactly how big list is. There's no way to see, oh, it's 5 elements long. So when we call a function, when we write a function, we have to have some way of providing the size. Now, we could write a function that takes in a length of 5. So this says, I take an array of integers that has to be size 5. Loop through them, do something with each one. Pretty silly, because that only works for an array of length 5. If I pass in some other length array, it's just not going to work. If I have something like this where I don't pass the size at all, I take in an array of integers of unspecified size, and I try and loop through it. I've got no idea how far to go. And I guess I could hard code it. So here's my array. So I'm going to rename this print array, and I take in the list. My loop has to know how far to go. There's no way to ask list how big it is, so I have to have something hard coded, which defeats the purpose of having an arbitrary size array. And I guess I could have some constant, but that's not a whole lot better. So typical behavior for when you want to write a function that can print any size list is to specify two things. You pass in an array, and for printing the array I don't care to change it, so that can be a const array of integers. And then you also pass in the size of the array, so that you can use that to determine how far you need to loop. Right, so if I'm passing in numbers, I'd say, okay, print array, here's the array, and here's its size. Now, so that's one approach, is I'd say, hey, print numbers, and there's 5 things. So int size, and now I can write my function like this and make my function be const. So that's one approach. And if I change numbers size, then I just got to make sure to change this as well. The other approach, you may notice I've got 5 sprinkled over multiple places, especially if you're working with an array that's going to be used all over the place in your program, or multiple arrays of the same size. It makes sense to have some kind of const declared, right? Some constant that says, hey, here's how many values we're working with in this program, and every list I'm working with is going to be 5 things. So I'm going to make something called numValues, which is 5, and then I can use that to set the size of my array. I could have my function, print arrays, kind of implicitly know that this is the size, and just loop up to that. This is probably less desirable than having the array take whatever size we want, because that way if I want to use this function for some other size array, for some other array in the program, I could still do it. So I'd encourage you to always write array-based functions with kind of this take in the array and then take in the size. But you will see sometimes constants used to define both the size of the array and then kind of how far functions should go as they work with that array. In terms of getting information back from a function, there's no way to have a function return an array. Right? Neither of these will compile. You can't say, hey, I've got a function make array that returns array of size 5 or returns undetermined size array. We cannot return an array. So the solution is to take in an existing array, and not as a constant, right, as a plain old array of integers here, so that we can modify it, so we don't want the const keyword, and of course the size, so we know how big it is, and then just go ahead and modify that array. So read array from keyboard function might look like print out, enter however many numbers, repeats that many times, read in to the current element of the list. Down in main, we could say, okay, I'm going to make a new array of numbers, initialize it to 0, and then call read array from keyboard, pass it the array and the size, and this function will do the work of going through, looping through the list, and modifying it. And because list up here is really just another name for the numbers array down here, when we come back from this function, numbers will have the appropriate values.